Okay, we're going to use long division first to divide, and then do a couple of examples of synthetic division, and then look at how we can use our calculator to find the roots of a polynomial. Okay, so the first thing we have is we're going to divide the polynomial 6x cubed minus x squared minus 13x plus 8. And we're going to divide that by 2x minus 1. So I am going to set this up as a rational function. So 6x cubed minus x squared minus 13x plus 8 all over 2x minus 1. So I have a rational expression. And what I'm going to end up with is the quotient q of x. And if I have a remainder, I'll put the remainder on top divided by my divisor, what I'm dividing by. Okay, so we set this up. I take the numerator and I put it inside, oops, I forgot the x, 6x cubed minus x squared minus 13x plus 8. And I'm going to divide 2x minus 1 into that. So we look at the leading term, 2x, and I'm going to send that into the leading term of my polynomial 6x cubed. So 2x times 3x squared, when I multiply, those give me 6x cubed. Then I'm going to multiply the 3x squared by the negative 1, the second term. So I get negative 3x squared. And then, just like long division, you're going to subtract the top from the bottom. So I get 6x cubed, and then I'm going to change all of my signs to a plus, and the negatives become a negative, and the minuses become a positive. Sorry, the positives become a negative, and then the negatives become a positive. So I get 6x cubed minus 6x cubed gives me 0, and then negative 1x squared plus 3x squared gives me 2x squared. I'm going to bring down the negative 13x. Now I'm sending in my 2x squared into, or 2x into 2x squared. So 2x times x will give me 2x squared. And then again, we're going to distribute to the outside. So I get 2x squared. And then x times negative 1 gives me negative x. And I then subtract. So all of my positives will become negative and all my negatives become positive. Okay, next up, 2x squared minus 2x squared is 0. Negative 13x plus 1x gives me negative 12x. And I bring down the 8, so the constant. Once I bring down the constant, we're pretty much done. So we just have to do one more long division here. So I have 2x into 12x. I end up with negative 6. Okay, so negative 6 times 2x gives me negative 12x, and negative 6 times negative 1 gives me positive 6. And then I change my sign. So because I'm subtracting, I actually have to add the negatives and subtract the positives here. Okay, so we get 0, and then 8 minus 6 is 2. This is my remainder of 2. So to put the remainder, I'm going to erase our, okay. To put the remainder, I put plus 2 over what I divided by, so 2x minus 1. So when I go back, I can see that 6x cubed minus x squared minus 13x plus 8 divided by 2x minus 1 is equal to 3x squared plus x minus 6 plus 2 over 2x minus 1. Okay, so one thing that this would tell me is that since when I divided by 2x minus 1, I got a remainder. So I know that the root or the factor of 2x minus 1 or the root of 1/2 is not actually a 0 in my polynomial. So only things that have a remainder of 0, only factors that have a remainder of 0 will give you a root or an x-intercept in your polynomial. Cool. Let's move on to the next one. Another example of long division, we're going to take 3x to the fourth plus 2x cubed minus 13x squared plus 9x minus 2 all over x squared plus 2x minus 4. One thing I notice here is that the polynomial that I'm dividing by, 2x squared plus 2x minus 4, is quadratic. So this is not a good candidate for, this is a quadratic factor, which means that I cannot use synthetic division. Okay, we cannot use synthetic division by dividing by anything other than a linear factor. So if you have a squared or a cubed or anything like that, you cannot use synthetic division. Okay, so I'm stuck with long division. I have 3x to the fourth plus 2x cubed minus 13x squared plus 9x minus 2. And I want to divide in x squared plus 2x minus 4. Okay, so I'm going to take x squared, see how many times that goes into 3x to the fourth, and that would be 3x squared. So 3x squared times x squared is 3x to the fourth. Then 3x squared times 2x is 6x to the third. 3x squared times negative 4, is negative 12x squared. And then I'm going to change my sign. So all the positives become negative and all the negatives become positive. I go ahead and add. I have 3x squared minus 3x, sorry, it's 3x to the fourth minus 3x to the fourth gives me 0. 2x cubed minus 6x cubed gives me negative 4x cubed. And then negative 13x squared plus 12x squared gives me negative x squared. Okay, bring down the 9x. Okay, we're going x squared into 4x cubed now. So I need a negative, it looks like, and then a 4, and then I'm missing one x. So 4x, negative 4x times x squared gives me negative 4x cubed. Negative 4x plus 2 gives me negative 8x squared. Negative 4x and negative 4 gives me 16x. Okay. Subtract, which changes my signs. So plus, plus, minus. And now I just add. So I get 0, positive 7x squared, add 9 and negative 16, which gives me negative 7x. And then I'm going to bring down the negative 2. We're going to do this one more time. So x squared goes into 7x squared 7 times. So plus 7. I'm going to distribute. So 7 times x squared gives me 7x squared. 7 times 2x gives me positive 14x. And 7 times negative 4 gives me negative 28. Yeah. Now, subtract, which changes all of our signs. Okay. So we get negative, negative, positive. Now I have 7x squared plus negative 7x squared gives me 0. The next, negative 7 plus negative 14 is negative 28x. Just kidding, that's 21. Try again. All right, negative 2 plus 28 gives me positive 26. Now I have nothing to bring down, so this is my remainder. So I'm going to add my remainder of negative 21 plus 26, 21x plus 26 over, what did I divide by? X squared plus 2x minus 4. So I can write my answer as 3x squared minus 4x plus 7 plus negative 21x plus 26 all over x squared plus 2x minus 4. Okay, that's long division. Now let's check out synthetic division. So I have synthetic division is really good when your divisor is a linear factor that has an a value of 1. Other than that, the rules get kind of weird with synthetic division. So if you just have like a plain old x plus 1 or x minus 2, so plain x or 1x plus something or minus a number, then it's easy to do synthetic division. But if you have anything else, honestly, I just do long division. Okay. And honestly, in real like applications, I use long division more often than I use synthetic division. Okay. So here's what we do. We take the root of the divisor. So x minus 1 would have a root. If I set it equal to 0, I see that x would equal to 1. That would be my root, okay? So next, so I put the root on the outside. And then on the inside, I put the coefficients of each one of my terms. So first, I'm going to start with the coefficient for x to the fourth, which is 4. Then x to the third, the coefficient is negative 10. And I leave a little space in between. The coefficient of x squared is negative 4. See, negative 4. The coefficient of x is 5. And the constant is also 5. Okay. What you do is you add. So I'm going to add 4 plus 0 is 4. And then you multiply by the root. My root is 1. So I do 4 times 1 is 4. Now we add. Negative 10 plus 4 is negative 6. Multiply negative 6 by the root. So 6 times 1 is negative 6. Then I add. So negative 4 plus negative 6 is negative 10. Multiply by the root of 1, which gives me negative 10. So I add. I think I can just. So 5 plus negative 10 is negative 5. Then I multiply by the root. So 5 times negative 1 is negative 5. Then negative 5 plus 5 is 0. So I can see that I have a remainder of 0, which means that this factor of x minus 1 goes into my polynomial evenly, which means that x equals 1 is an x-intercept. Okay, but how I'm going to write this in division is that I divided out an x, so I'm now going to start with x cubed instead of x to the fourth. So the 4 represents the coefficient for x, for the x cubed variable. Then for the x squared variable, let me write it down here. X cubed, x squared, x, and then your constant. So we get negative 6x squared minus 10x minus 5, and there's no remainder. All right, let's do another one. So 3x cubed minus 10x plus 21 divided by 3x minus 3. So my root of x minus 3, I set that equal to 0, and I see that x is equal to 3, so the root is 3. So I put that on the outside. On the inside goes the coefficient of x cubed, x squared, x, and the constant. You don't have to write these up here, okay? So I'm going to write my coefficient of x cubed is 3. My coefficient of x squared, there is none, so I put a 0, and you need that placeholder, otherwise it's going to get messed up, okay? Then for x, the coefficient is negative 10, and for the constant is 21. All right, so we bring down the 3. Then we multiply by the root. So 3 times 3 is 9. We add. 0 plus 9 is 9. 9 times 3, 9 times the root is 27. We add to give us a positive 17. And then we multiply 17 by 3, which is 51. So I end up with a remainder of 72. Since the remainder isn't 0, then I know that x minus 3 does not go in evenly into the polynomial, so 3 is not an x-intercept. Okay, so I end up with, remember you reduce the power, so x cubed becomes x squared. So I end up with 3x squared plus 9x plus 17 plus 72 over what you divided by, which was x minus 3. Okay, the next part is in your calculator. So to find the zeros, we're gonna find the zeros of this polynomial x, 4x to the fourth minus 43x squared minus 9x plus 90. The first way to do this is to use the graph in your calculator. So I have my calculator, maybe. Okay, I pressed the y equals button and I typed in the equation 4x to the fourth minus 43x squared minus 9x plus 90. And I'm going to go ahead and press graph. And I notice, so my graph is in, the window is from -10 to 10 in the x and -10 to 10 in the y. And I noticed that really the graph zeros only happen between like negative, like if I switch the window to be from -5 to 5, I could still see the roots really well. And then I probably need to make the y values taller so that I can see the curve, the top curve of the graph. And one clue for me is that the plus 90 is the y-intercept. So I'm going to press window and I'm going to change the x, or the domain, the window domain of -5 to 5. Okay. The scale is the tick marks. So every 1 unit, I see a tick mark. Okay. Then for the y min and the y max, since the y-intercept is 90, I'm going to go change this to -100 to 100 and see what happens. Okay, and then I'll just keep the y scale. Every tick mark is worth 1, but it's going to look like a solid line because there's the tick marks are so close together. So I can see now that the roots happen. So the curve kind of looks like it goes really high. Let's see. Just gonna like sketch it in here. It goes like really, that's not the best sketch. We can do better. Okay, and I know this point is 90. And then for the x values, I need to know exactly where these x-intercepts are. And so like, especially the ones that are not, that are in between two tick marks, in between your scaling, we want to get an exact value. So how we do this is press second, calc, 0, so 2. It asks for the left bound, so I'm going to scroll all the way. I'm going to choose a x value that is left. So here's where I think my 0 is. It's about right there. Like that's the first 0 that I see. So I'm going to go left of that 0, press enter. Okay, and you see it like creates a boundary, and then I need to create a right side boundary. So it has to be before the next 0. So I see there's a 0 here at like -2. So I want to make sure I choose an x value that is to the left of -2, but to the right of my 0. Okay, then it says guess. I press enter again, and it tells me my 0 is at -2, comma 0. So I have one root right here at -2.5. So I have an x-intercept at -2.5. Where else do I have an x-intercept? Well, you have to do this again. So I'm going to do second, calc, 2 for 0. And this time I want to make sure that this x-intercept really is at x equals -2. So I'm going to scroll to the right. So when x is equal to -2.27, so to the left of the root that I'm trying to find, and to the right of the last root that I had. So I create a boundary line on the left, and then I'm going to create a boundary line on the right. So it just needs to be to the right of the root. So I don't know, I can go all the way over to here if I want. Okay. And so what you're telling the calculator is like, hey, look in between these two boundary lines for an x-intercept. Everything else is gone. Okay. To the calculator at least. So it says the 0 is at -2, comma 0. So right here, we have another x-intercept at -2. Okay. So another way to test your root is, I think there's an x-intercept at 1, 2, 3. So you can press trace, and then type in the number 3. And if your y value is 0, you have a x-intercept, okay? So right here, you have another x-intercept at 3. I'll put them in order. And then for the last one that's maybe at 1.5, again, you can use your 0. So I'm going to go, it says left bound. So I'm going to go to the left of where that 0 is. So I don't know, like x equals 1.12. Sure. That's to the left. And then to the right, something like that, but before the next x-intercept. Okay, guess. So the 0 is at 1.5. Okay, for a sketch, that graph was not that bad. Okay, so that's how you find the zeros on your calculator. Okay, now we're going to use our calculator to find the zeros using our using the calculator, but using like a little different program. So it's called the Poly Root Finder, which I call the Poly Smelt. What you do is you press apps, and then you go to number 9, the Polynomial Simulator 2. Okay, so I'm gonna press 9, and I'm gonna use number 1, the Polyroot Finder. Okay, so what I need to do is look for, the order is the degree. So I have a 4th degree polynomial, so I'm gonna change this to a 4, enter, and then the normal, float, and then radians and degrees are only for trig, so it doesn't really matter because this isn't a trig problem. So I'm going to press, for next, I press graph. So all of the buttons underneath tell you, so this tells me what the command is, but the button underneath will actually do that. So A4 is your coefficient, your leading coefficient. So in our case, A4 would be 4. A3 is negative 43, A2 is negative 9, and A1 is 90. Just kidding. We don't have an x cubed, so A2 is 43, A1 is negative 9, and A sub 0, your constant, is 90. So I have 4 as my leading coefficient, 0 as my x cubed term, negative 43 as my x squared term, negative 9 is the coefficient on x, and 90 is my constant. Then I press solve, and it tells me, hey, look, your roots are x is equal to 3, x is equal to negative 2.5, x is equal to negative 2, and x is equal to 1.5. Look, matchy matchy. So this is just 2 different ways that you can solve for the x-intercepts on your calculator. All right.